video is on lesson 6.2. Lesson 6.2 is talking more about factors and divisibility. Now, divisibility is one of those things that we talked about in the vocabulary section. So we're going to do this explore and grow, and I'll go over it with you. And it says to list any 10 multiples of 3. And what do you notice about the sum of the digits in each multiple? Okay, so multiples, if you remember in our vocabulary section, multiples are the numbers, the answers to multiplication when we are multiplying by a certain number. So it wants some multiples of 3. So it's the answers when we multiply any number by 3. So let's start listing them out. We can just start with 1 times 3. 1 times 3 is 3. So that's a multiple. So we need to do 10 multiples. So the easiest thing to do would just be 3 times 1, 3 times 2, all the way up until 3 times 10. Alright, so let's do that. 3 times 1 is 3. 3 times 2 is 6. Okay? 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. So we have 1, 2, 3, 4, 5 so far. I'm doing good. 3 times 6 is 18. 3 times 7, 21. 3 times 8 is 24. 3 times, where are we? 3 times 9 is 27. 3 times 10 is 30. Okay, so that is 10 multiples of 3. You could do 3 times 100 if you wanted, or 3 times 11, 3 times 1000. Okay, all of those answers are going to be multiples of 3. The easiest is just to do that number times 1 through 10. Alright, so then the second part asks us, what do I notice about the sum of the digits? Okay, so the digits are the numbers that make up a whole number. Okay. So the sum is the answer to addition. So if you were to add up, well, this is just 3, right? Just 3. Just 6, just 9. What if you were to add up 1 and 2? You would get 3. If you were to add up 1 and 5, you would get 6. If you were to add up 1 and 8, you'd get 9. What about 2 and 1? You'd get 3. 2 and 4, you'd get 6. 2 and 7, you'd get 9. 3 and 0, you would get 3. Now if you notice, the sum of the digits in each multiple is divisible by 3. Because we have 3, 6, 9, this sum is 3, this one is 6, this one is 9. This one is 3, this one is 6, this one is 9. Okay, these are all numbers that are divisible by 3. So a way that you can tell if a number, if 3 is a factor of that number, would be to add up the digits. So if I were to give you some big number like 141, okay, you would look at that and if I were to ask you, is this a multiple of 3? Can 3 times something equal 141? You would add up these digits. You would say 1 plus 4 is 5, and 5 plus 1 is 6. 6 is a multiple of 3, right? 3 times 2. So 141 is a multiple of 3. 3 times something would give you 141. Okay, so that is one way, that is a rule for 3s to know if a number is divisible by 3. So you add up the digits. And if the sum is 3, 6, or 9, then the number is going to be divisible by 3. Okay. List any 10 multiples of 9. What do you notice about the sum of the digits of those multiples? Okay, so we're finding the multiples of 9. So again, the easiest way to find multiples is to just start with 1, and it wants 10 of them, so go from 1 to 10. So 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. 5 times 9 is 54, 6 times 9, I'm sorry, 45. Whoops, got ahead of myself. 5 times 9 is 45. 6 times 9 is 54. 7 times 9 is 63. 8 times 9 is 72. 9 times 9 is 81. And 10 times 9 is 90. All right. Now, it says, what do you notice about the sums of those digits? Well, 9 plus nothing is just 9, right? What is 1 plus 8? It's 9. What is 2 plus 7? It's 9. What is 3 plus 6? It's 9. What is 4 plus 5? It's 9. 5 plus 4? 9. 6 plus 3? 9. 7 plus 2? 9. 8 plus 1? 9. 9 plus 0? 9. Okay, the sum of those digits are all 9, which means that the sum of the digits is divisible by 9. Okay, so then our last question asks, how can you use your observations about 3s and 9s to decide whether 3 and 9 are factors of any given number? Well, you find the sum of the digits like I did with the 141. If the sum is divisible by 9, then 3 and 9 are both factors. If the sum is divisible by 3, then 3 is a factor. So if you add it up and it's divisible by 9, then 3 is also a factor, right? Because 9 is divisible by 3. If you add it up and it's 3 or 6, then 3 is a factor, but 9 is not. All right, so let's look at some of the rules of divisibility. A number is divisible by another number when the quotient is a whole number, when the answer when you divide is a whole number and it does not have a remainder. Okay, so some numbers have a divisibility rule that you can use that makes it a little bit easier to determine whether they're factors of a number. There's a rule for 1. 1 is a factor of every number. So 1 is always going to be a factor. Okay, 2. You can know if a number is divisible by 2 if the number is even. So you look at that very last digit. If it's a 0, 2, 4, 6, or 8, it's an even number. 2 is divisible. Or it's divisible by 2, sorry. Okay, we just figured out the rule for 3. If the sum of the digits is divisible by 3, if you get 3, 6, 9, 12, right? Those are numbers that are divisible by 3. Then 3 would be a factor. 5, I think we talked about it a little bit in our last lesson. If your number ends with a 0 or a 5, then it is divisible by 5. Because those are, when you count by 5s, you get 5, 10, 15, 20, right? It alternates 5, 0, 5, 0, 5, 0 at the end. So if it ends in a 0 or a 5, it's divisible by 5. The rule for 6. Now this is a two-part rule. If the number is even and is divisible by 3. So like 12. 12 is even and it's divisible by 3. Which means it's also divisible by 6. 18. 18 is even. It's divisible by 3, so it's also divisible by 6. So it's not enough that it's divisible by 3, it also has to be an even number. That's the rule for 6. The rule for 9, we figured out if the sum of the digits is divisible by 9, then the whole thing is divisible by 9. And then 10s. If the number ends with a 0, because 10, 20, 30, 40, 50, all of the multiples of 10 end with 0. So if the number ends with a 0, then the whole thing is divisible by 10. Alright, so you're going to fill in this chart to find the factor pairs for 48. So, 1 is 48 divisible by 1? Yes, because remember, 1 is a factor for every number. Okay, so the multiplication equation would be 1 times 48. Okay, 2. Is 48 even? Yes. So 2 is a factor. So then you'd figure out the multiplication. 3. Does 4 plus 8 equal a multiple of 3? Is 4 plus 8 divisible by 3? What is 4 plus 8? 8, 9, 10, 11, 12. 12 is divisible by 3. So 48 is divisible by 3. Let's see. 4. There's not a hard and fast rule for 4, so that one you would just need to know, can I divide 48 by 4 and get a whole number with no remainder? Well, 48 divided by 4 equals 12 with a remainder of 0. Is that true? Yes, it is. Okay, so yes, 4 is a factor. And if you notice, this is not a hard and fast rule, but 4 is divisible by 8, or I'm sorry, 4 is divisible by 4 is divisible by 4, and 8 is divisible by 4. Okay, that's not always going to be the case for 4s, but in this case it works. So 4 is a factor. 5. Does it end with a 0 or a 5? No. 6. Remember, is it even and divisible by 3? Well, we know it's divisible by 3 because we did that part already. Is 48 an even number? Yes, it is. So it's divisible by 6 as well. Okay, 7. There's no rule for 7 other than to divide. So 48 divided by 7 equals 6 with a remainder of 6. Okay, so you have to have a remainder of 0 for it to be divisible by 7 is not divisible. Or 48 is not divisible by 7, I'm sorry. And then 8. There's no rule for 8 either. That's another one you'll just have to divide. 48 divided by 8 is 6 with a remainder of 0. So it's got that 0 remainder, so yes, it is a factor. Now if you notice, 4 divided by 8, or 48, sorry, divided by 8 is 6. So 8 times 6 is 48. Well, we already did 6, so we've started repeating ourselves. So we're done. Because remember, once you start repeating yourself, then you're finished. So the factors of 48 are, so then you look over here, so you'll need to complete your multiplications, and you'll look over here, and you'll say, well, my factors are, and then they've listed them in order from least to greatest. So your first one would be 8. Your greatest one, or your first one is 1, I'm sorry. Your greatest is 48, and so that would be at the end. Now, it's not super important right now that you put them in order from least to greatest. That's just how the answer book gives it. So if you want to do 1 and then 48, that's fine as well, as long as you list all of the factors. Then 2 and whatever you got for 2 times to get to 48. And then 3 and its factor pair, 4 and its factor pair, 6 and its factor pair, which we discovered was 8. So your last one is going to be 6 and 8, because you're not going to put also 8 and 6 because that's already in there. Alright, so hopefully these rules will help you out a little bit. You can definitely go back to this and look. And then once you turn in this page, you can always come back to this video and just pause it right there on this page so you can see those rules if that helps you. So you're going to be identifying the factor pairs. And you're going to be doing this. Now you have this other information that can help you. So you could still, you can still list them out. 1 and this one is 30. So 1 and 30, it's an even number. So we know that 2 is going to be one of them. It's 3 and 0. So we know 3 is going to be one of them, right? Because 3 plus 0 is 3. It ends with a 0. So we know 5 is one of them. So that can help you. These rules can help you a lot in finding all of your factor pairs. All right, so let's look at some of the word problems, the modeling in real life. All right, there are 4 classes going on a field trip. The classes will use 3 buses. Can the teachers have an equal number of students on each bus? So here is our 4 classes, here are our 4 classes, and the number of students on each one. All right, so our first step would be to find out how many students there are altogether. So you're going to add up the number of students. So they've done that here, 24 plus 23 plus 25 plus 20. A lot of times it's easier to add if you do them vertically, if you stack them. So I'm going to do that here just to kind of help ourselves out a little bit. 24, 23, 25, 20. Okay, because then our 1s and our 10s are lined up. All right, so 4 plus 3 is 7. And then 7 plus 5 is 12. So we'll put our 2 here and we'll carry our 1. Okay, we've got 2 plus 2 plus 2 plus 2 plus 1. So we've got 2, 4, 6, 8, and then 9. So there are 92 students. Our second step is to find out if the total number of students is divisible by the number of buses. There are 3 buses. So we need to know if this number is divisible by 3. So remember, we take the 2 digits that we found, and we add them up. What is 9 plus 2? 9, 10, 11. So you'll put here 9 plus 2 equals 11. Okay, now is the sum of those digits divisible by 3? Is 11 divisible by 3? No, it's not. Okay, so the sum of the digits is not divisible by 3. So can the teachers have an equal number of students on each bus? They can't. Because there's not a number divisible by 3. So make sure you still are using those rules that you have learned, that you've gone over, and to help you with your word problems as well. All right, so that is lesson 6.2. Remember these rules, and if you need to, come back to this lesson and look at that chart for those rules, as we continue on talking about if a number is divisible by, if it's a factor of a number or not. All right, so that's it. As always, if you have any questions, let me know. I'm always happy to help you, and I will see you next time. Bye.